everyone. Welcome back to the panel on technical limitations of ChatGPT. So I want to thank our panelists, Mikhail Belkin, professor in HDSI, Xiting Hu, also professor in HDSI, Dheeraj Makala, PhD student in HDSI, and Zihan Wang, PhD student in HDSI. So I want to start with a question about your experiences with ChatGPT, where you've seen it succeed and where you've seen it fail. So while ChatGPT has surprised many with its abilities to do complex tasks, such as solve that puzzle I showed early on today, it can also fail at relatively simpler tasks, like counting the number of words in a sentence. So can you characterize the task that ChatGPT maybe doesn't excel at? What does it struggle with, and why does it struggle on problems like that?
Yeah. In my experience, the ChatGPT specifically struggles with problems involving multi-step reasoning and any mathematical reasoning and logic. So, for example, if it has to use its previous answers to answer the next question. For example, if there is a query, how many World Cups did Italy win between 1960 to 70 when Pele played and India was ruled by Great Britain? So there are like so many complex queries in that, and it has to answer each one of them and aggregate. Sometimes it gets it right and sometimes it does wrong. And as you have said, the counting, anything that involves reasoning and computational logic, some mathematical reasoning stuff, it gets wrong. That's what I observed in my experience. And to answer the next question, why does it get wrong? Because it was trained on next word prediction task. So the first thing, the next word prediction task doesn't necessarily explicitly ask it to learn the logical part of it. And also the second thing is, once it gets a single token wrong, there is no way of fixing it back. So there is like an exponential. The probabilities of getting it wrong gets exponential high as it generates longer sequences.
Okay, yeah, and also what I observed is that ChatGPT sometimes it cannot faithfully answer what it actually knows and what it actually doesn't know. So for example, if I just ask him who Zihan Wang is, and it will try to make up something that looks logically correct. Maybe it saw my personal website online. It will scratch some of them, but say that I'm a postdoc at CMU, which is absolutely incorrect. I never searched as Zihan Wang at CMU. So it tries to make something correct. So it has this ability of generating fluent sequences that somehow matches certain keywords, but it doesn't really know what are the correct factual knowledge that exists in the world. So that's kind of one of its limitations, I think. And the reason that it isn't able to answer that, I feel like it's partially because of it's never trained on such data before. It never has the enough exposure to data such that it needs to faithfully answer that. I never saw this thing before. I have to say I don't know. Probably it was trained on a bit of it, but it's not enough to match all the abundant knowledge that it hasn't been exposed before.
Right. So I kind of want to follow up on that, the problem of hallucinations, because I think maybe the first thing you might think of is, well, why can't it just cite its sources? What are the technical limitations that would prevent a large language model from saying, this is where I found this information?
Yeah, I think the research for citing its source is currently happening, and there are even some, for example, UChat, I think it cites its sources. Yeah, so this is exploring, this is the research that is being explored now to cite its sources. But as Zihan said, the space of possibilities and impossibilities, the space of impossibilities is comparatively much larger than the space of possibilities, and it is not being exposed to the space of impossibilities to say that it is not possible or it doesn't know about that. And citation might fix it, and it's the research is going on towards that.
So earlier, Jingbo talked about how large language models are growing in size in terms of number of parameters, also in terms of the size of the data set that they're being trained on. And so I want to ask, the current deficiencies of LLMs, where we see them struggle, do you have a sense that it's just a matter of increasing the amount of data, increasing the number of parameters, or increasing the number of GPUs? What are sort of the bottlenecks to improving the performance of the models? What do you see as the trajectory there?
Yeah, okay, so I think, scaling, right, in terms of data and the model size, will definitely kind of further improve the performance of ChatGPT, right? We saw, like, say, GPT-4 is kind of better than GPT 3.5 on a lot of problems, and maybe GPT-5 is even stronger. But I don't think scaling is everything. As the other panelists, they mentioned those problems, right? ChatGPT cannot work well at this point. For some of the problems, I don't think scaling can solve them. So one particular example is, those problems that requires, explicit tracking or maintenance of the world state. Like, say you tell ChatGPT you have an apple in the fridge, and then you took that apple and put it on the table, and then you continue to tell ChatGPT that you did a bunch of other things, like, say, whatever, like you replied an email, you drove to the campus, whatever, and then you ask ChatGPT, where's the apple? ChatGPT cannot answer that because it basically does not track the status of the state of the world. It's just a kind of language model that's simulating the next words. So that's kind of a fundamental limitation of the formulation, I think.
Yeah, I also feel that scaling, well, on one hand side, we consistently have seen that scaling the number of parameters and the number of the amount of data has led to improvement in performance. So no doubt that more data and more parameters will help. I'm also, I think there is a limit, like even when we go to effectively infinite number of parameters, there is a limit to how much performance you can squeeze out of that. On the other hand, I would like to say that what we have seen, if you told me 5 years ago that these models would do what they're doing now, I wouldn't have believed it. So I think our predictions should be maybe taken with a little bit of a grain of salt. We didn't see this coming, so I'm not like super confident that, yeah.
Yeah. So I guess to summarize, would you consider any of the limitations right now to be fundamental to the model itself, the technology, transformer architecture? Or is this just going to be, it's just a matter of more data?
So I would say the formulation or next word prediction it has the fundamental limitations, basically. You have, there are a lot of things you need to model, basically, beyond the language and beyond this next word prediction. So that's my take.
Yeah, I my rational mind sort of agrees with that, but honestly, I don't know. I think.
I have a small point to add. I mean, for the next word prediction, our intuition behind that is like, as you scale up the model and as you increase the data, the model sort of understands the context in a better way to predict the next token. But as Professor Zitting said, it doesn't remember the state very well. If even if you increase the model, or even if it increases the data, so there is some fundamental limitation that I believe for the next token prediction task.
Yeah, I can add another different perspective. I think it's slightly different. So I feel like if ultimately we just want a machine that can answer all the questions, then it's possible that we can just regardless of human effort, just gather all the possible questions in the world and just annotate them all with a wrong truth answer and feed it to the model to train it. But the crucial point here that I view is that the data is just like too much. Like we cannot afford to really gather all the possible questions. We cannot afford to actually annotate all the possible questions. And we have to rely on the model to generate some of the questions to answer the other questions. And that point is what I feel like could vary very differently, like between like some tasks that is easy to generate and some tasks that will be hard to generate. And the logical tasks that was just discussed before, I personally view it as some tasks that is quite hard to generate because first, it doesn't really naturally exist in online data, and second, it doesn't really it's kind of like the learning to the function that maps the input to output could be very hard for the model to understand because it involves like complex logic. So for me, like the architecture-wise, or the I'm not sure if transformer is the best, but I feel like it's more on the training procedure side. How do we actually allow the model to train in a way such that it learns how to generalize better? That is another limitation that I feel like could be the bottleneck.
All right, thanks. So speaking of training these models, they're trained on large amounts of text data on the internet. And it's speculated that large amounts of the internet will become generated by AI in the next few years. So the question is, does this pose a problem for the training of the model, given that it's trained on its own output?
I personally won't be concerned much about training the language models in future using AI-generated data because there are techniques being developed to identify the AI-generated data. So I guess we can always filter very accurately to identify the human-generated data out of and the whole internet and just train based on that. But I think the more difficult problem to solve is it's not very evident for a human to say this is AI generated or human generated, whereas algorithms can do that, but for human it's difficult. So I think the disinformation will be a bigger problem than training data for language models.
I do have a worry. People are using ChatGPT to help them, write text, or ChatGPT to produce whatever they want to write. So we do have a project trying to study this problem. We call it pollution by those large language models, to the web. So, it's not just about like say all the training data on the web, are created by language model and how that would impact the next, say, GPT-5. We may also worry about, how the use of ChatGPT may impact the human, language, right? Like say ChatGPT may have some pattern or bias on using some of the words instead of other words. Would this gradually reshape, how we human use language, right? And would that eventually lead to the change or shift of even our human culture, right? So that's kind of the problem we're kind of thinking about. Of course, it's kind of a very high-level abstract problems when not sure yet.
I want to talk a little bit about the sense in which these models develop a world model. I realize this is very speculative, but in the intro today, I gave a problem where I said there were two rooms, and each room has a window on the north side. And Alice is in the first room, and Bob is in the second room. And they couldn't hear, they had earplugs in. And there's nothing in either of the rooms, but Alice has a cell phone. She's going to get a message, and she has to relay the information that she got a message to Bob. And the model said that what she should do is shine the flashlight of the cell phone out the window onto the ground so that Bob could see the light and infer that she received a text message, which seems to suggest that the model understands a lot about the world, right? And so I guess the question is, these models are trained just to predict the next word, right? Do you think that's enough for these models to build a rich understanding of the world like we have? Can it emerge from that sort of training process?
Well, I think it's very tempting to say that we have a unique ability to build world models, but it's hard to see why it cannot have a world model given that what we observe about its behavior. I mean, if you think about the human intelligence, it's a product of, like few billion years of evolution, right, which allowed us to build the models that we have. Certainly, for each individual human, we learn from much, much less data than those models have. But it's sort of, I don't see any fundamental reason why a world model cannot be obtained from this sort of collective output of, human thought that it's being trained on. I think an issue with that, of course, is that the models, at least as they are now, they don't have access to the physical world, and they only have access through the social construct that the humankind produced. But as far as the model is concerned, I would say that probably we can argue it has some sort of world model.
Yeah, I agree. Like, I do think large language models are a type of world model because they are modeling language, and the language itself is a representation of the world. Right? We use language to describe the state, the action, right, and then how the state will change. So, as for example, network prediction model is a world model, right? So. But the problem is that language is ambiguous, and the language is very noisy. So that kind of determines that the large language models are noisy and kind of ambiguous. Also, language is not many times, it's not the most efficient representation of some of the world states. Like say we have two chairs here. You want, and my question is, what are the differences between these two chairs, right? So you can use language to describe the difference, but it's very difficult. You have to say a lot of things. There are a lot of nuance differences here, right? So sometimes it's easier to just post the two images, right, of the two chairs, right? So images are more efficient representation for this particular question, right? So. Large language models using language to represent the world or to kind of model the world is very powerful because language is powerful, not because network prediction is powerful. But it's not complete, and it's not efficient enough in many cases.
Thanks. So I want to catch up on time, but I guess last question, any bold predictions for the next 5 or so years? I won't put you on the spot, but I just did. Yeah, I think this is motivated by Minsky saying in 1970 that in the next 8 years we'll have human-level AI, and I think if he were alive today, he might make the same claim again.
I won't make any bold predictions, but. Sebastian Bubek from Microsoft, who is actually a theoretician, leads the theory group at Microsoft Research. He has been giving talk. They just published a 100-plus page paper on various aspects of GPT-4. They got to play with it earlier than other people. And he's been going around giving this talk titled First Contact. So,
Though I suppose it should be stated that Microsoft, which Bubek works for, is a large funder of ChatGPT.
That's a very fair point.
Yeah. All right, so I want to thank the panel for their participation today.